I have this ball that I've made, and I've kind of got it so when I click a mouse, it will change the speed and update the position using the speed value. And when it goes up a certain direction, it will turn around and hit the ground there. Like and it's kind of like so primitive attempt to make something jump, right? Here, let me up the value a little. Maybe I'll take this to 4 here, there. And well, it seems no matter what you do, it just doesn't quite get that kind of realistic motion. And the reason for that is, it's a linear motion, right? Let me copy in a little for loop here. You can see that these are all evenly spaced in my for loop. Here I have updating using a value of 30, which would be 30 pixels in distance apart here. You could think of that as our speed variable, essentially, if this was over time. But here, what we really want is for this to be more kind of exponential. And so, okay, well, you go on Google, lead you in the search of gravity, and basically, you look all over on the forums, and you want to, somebody's asking, how do I make a ball fall using gravity, and you get back all these answers that, look something like this, and this. Well, F is the force of m to the first power and m to the second power. You're like, okay, well, great. Well, how do I convert all that to code? The problem with all that is, that's Newtonian physics. Is dealing with seems to be primarily the gravitation of a couple of planets. And then of course two guys break into an argument, or 3 or 4. And the other guy's, no, you want to do this, and the kid's question is never answered. I feel so bad for all these poor kids. It's like what they want is this. It's pretty obvious, right? See, it starts out fast, and then as it gets up, it slows down to a complete stop and turns around and comes back. Whereas Newtonian physics is dealing more with this. You can see this object, the bigger object, is being attracted toward the smaller object, just a lot less because of its mass, and so these are two objects in space, in theory, and so one could even say, if there's a speck of dust out in space somewhere and it's falling towards the Earth, that the Earth is actually being pulled toward the speck of dust, equally, but of course because of its mass, huge size of the Earth, that the amount that it's being pulled is negligible, but nonetheless, that is gravity and quantum mechanics, and all that general relativity. Okay, but great. I just want to figure out how to make a ball fall. Thanks a lot, Einstein, for the going off. So basically, here's one method be using sine and cosine, to simulate a more realistic trajectory, and as you can see from this illustration here, that here things are speeding up, starting out nice and fast, and as they come down, as they reach their apogee, the highest point, they slow down to a complete stop, and then slowly increase in speed on the way down. Now you can note that all of these points on this chart here correspond to this circular path, the spokes on the wheel. This point is equal in height to that point, and this point is equal in height to that point. You see that So there was this like circular motion involved to a realistic looking gravity. If I was here and I threw a ball into space, it'd follow a path kind of like that, more or less. Same thing, though. The circular motion is still there in our y value, right? And imagine like this is frames in this direction, right? Now, the moment something leaves your hand, its y is going to be, it could be infinite. It would just go on and on like forever, theoretically, not factoring in wind resistance and stuff, until it hits the earth. It's literally a ground to a halt. Okay, so like one method of expressing our Newtonian physics is an Euler equation. It looks like Euler, but it's pronounced Euler. So not to disrespect the family or anything, Euler gravity. And the way that works, here's kind of the full breakdown of it, of all the Newtonian gravity equation, or one of many, really. Where, let's say, our time step, represents our frames. Like, let me go 1.1 here. And I could, bring this down. And that would be like I was taking more frames per second of the same. Imagine this is a ball being thrown in the air, and the whole thing takes 3 seconds, right, in time. And I'm taking 10 snapshots, so that that means my camera can is so fast, right? But if I got a faster one, then the duration of time between frames essentially becomes less. So that's your time step. So we really don't need to worry about a time step because in our animation, the duration is the duration between one frame and another, and that's kind of like built in. So I can eliminate the time step, which before was in reality a constant. Like same with our mass. We have a mass of 1 in this equation. Time step plus equals 1. See, force divided by mass, works well in the equation, of determining, gravitational pull between a couple of objects in space, but we're only dealing with one object being attracted toward one Earth, and the mass is kind of constant in here, so it would actually be mass. Mass is a constant. But since it's always 1 in this case, then like dividing by 1 all the time is kind of futile, really. So we really don't even need mass. To be honest with you. So that means we don't need these little quotations or parentheses to ensure that is calculated first, or any of that, so get that out of there. Same with our time. Later, we're not going to need to calculate time in, because the time is, how long our draw loop. This will be, replaced with our draw function. So that takes care of our time. So that just boils the whole equation down to this. Don't need it. We won't need time. Force in our case is our gravity. Really, you see. So force like that plus, and here velocity equals velocity plus gravity. I can just say plus equals gravity and position plus equals velocity. That's our equation. Euler kind of simplified for our purposes. Okay, that'll come into play in our next video. One more thing, of course, here, velocity. We've declared a velocity. In the past, I was calling that speed, in my programs, which I mean technically that is velocity. So if you want to get technical, which we are in this case, velocity, but it's no longer a constant. When we're going to be factoring in gravity, our velocity is going to change, you see. So a little bit different use now. Same things. Let's get on and make some things jump, shall we?